Hi, welcome to the second movie about the mathematics behind AI. Last video we've seen what it means to be a set. In this video we're going to look at a new concept called subsets. So suppose we have two sets which we often denote by a capital letter, so capital letter A and capital letter B. Then we say that the set A is a subset of B. Well, this means that if every element of A is also an element of B. So very simple, but what you see is I already need a few words to write this definition down. So what do we want? Well, mathematicians are often lazy, so we're going to introduce a new symbol to write down this expression a lot quicker. So what we use is this new symbol. Like this is a capital letter A upside down, which is read for all. For all elements of a subset, we often use small letters for that. For all A an element of the subset A, so this is to be read an element of. Then we use a colon, which reads it holds. It holds or it holds that. Well, B is, oh no, not B of course. A is also an element of B. So convince yourself that this symbol for all A, an element of set A, it holds that the element A is also an element of the set B, is exactly the same as saying every element of A is also an element of B. Well, some examples. The infinite sets we saw last time, of course. The natural numbers are a subset of the integers, a subset of the rational, subset of the reals, and if you want to continue, a subset of the complex numbers. You can also embed this one in the quaternions. It doesn't matter. And we're gonna give some more examples because this will allow us to introduce even more notation and terminology. If you want to look, for example, at the set of even numbers. Well, how can we write this down? So this is, of course, you can say this is every integer, and I use a new symbol here. This is this vertical line, and this reads for which it holds. So everything that will come behind this will give a condition on what is written on the left of this line, for which it holds that number 2 divides n. So these are indeed even numbers. It is an integer which is divisible by number 2. Well, that's often in mathematics there are multiple ways of saying the same thing or representing the same concept, in this case the same set. We can also write it just as a notation as 2 times the set of integers. Or we could also say these are all the elements 2 times n, for which it holds that n is an integer. These are all similar expressions for the same set. And of course we're dealing with subsets because everything happens inside the set of integers. So this is indeed a set or a subset of the integers. So we've seen especially this guy here, this notation for which it holds, which allows us to give extra conditions. And now let me give some more space, wipe this out. Cool. Because I've told you we're often going to work with the real numbers. So let us look at some subsets of real numbers. So you know that the real numbers, we can represent them on a line. Every point on the line corresponds to a real number and vice versa. For example, if I put here if I put here the element 0 and here the element 2, and I want to look at the set. I want to look at the set every real number x for which it holds that 0 is strictly smaller than x and x is lesser or equal than 2. So I want to exclude 0, I want to include 2, and I want to consider all these real numbers in between. So of course this is a valid way of expressing this set, but we often going to use, because this is an interval, it's a consecutive, it's an uninterrupted subset of real numbers. We can also use like these square brackets. We can use this notation. This is exactly this subset. So the real numbers in between 0 and 2, and 0 is excluded because you see that the bracket, the legs of the bracket are outwards directed, and here you see that 2 is included. Well, similarly, we could look at the set x, all real numbers for which it holds that x is smaller than -5. We can use this as all the real numbers starting from -infinity. -infinity is not a real number, so we have to exclude it until -5, and -5 is also excluded. So this is this notation that we can use to make a lot of subsets of the real numbers. And to end, maybe an exercise, well, so this is an exercise, give 2 expressions for the set of integers that have remainder 3 when dividing by 5. We've actually seen almost every notation to give 2 expressions, so I leave it to you to be a bit creative. Well, the first thing that you could do, we call this set for the set A. I could say, okay, with the accolades expression, so it's a subset of the integers, so I say n is an integer for which it holds. Well, there exists, this is a new symbol, there exists an integer k such that it holds that we can write n as 5 times k plus 3, because this is exactly saying that if you divide n by 5, the remainder equals 3. Or you could say, well, we're just going to look at all the multiples of 5 and we're going to add in 3. This is the short version of this set. Next video we're going to look at what we call operations on sets. Ciao.